In Chapter 7, we will be dealing with a lot of exponent problems. So here in Section 7.1, we're going to start looking at exponent properties, and this is just our first look at it. We're splitting 7.1 into two parts. So here's just day one of Section 7.1. So the first property that we're going to look at is the product of powers property. It says, let A be a real number and let M and N be positive integers. So it says, to multiply powers that have the same base, add the exponent. So if I wanted to take a to the m times a to the n, I would just take a and then add the m and n together. So if I have 5 to the 6th power times 5 to the 3rd power, so the bases are the same, I would just take the 6 and the 3 and add them to get 5 to the 9th power. So when you're multiplying, you add the powers. So here's example number 1. Use the product of powers property. We're just going to leave our answers in exponential form, meaning if I'm going to take 3 to the 3rd, I'm just going to leave it as 3 to the 3rd rather than multiplying out what 3 times 3 times 3 is. I'm just going to leave it with the exponent. So part A says 4 to the 7th times 4 to the 6th. So I have the same bases, so I'm just going to add the powers. So I'm going to keep the same base, which is 4. I'm not going to take 4 times 4. My base is still going to be 4, and then I'm just going to add the powers. So 7 plus 6 is 13. So my final answer would be 4 to the 13th. For part B, I have 8 to the 5th times 8 times 8 to the 2nd, or 8 squared. Whenever there is not a power written, it's implied that it is 1. So since I have the same base, 8, 8, and 8, my base of my answer is going to be 8, then I'll just add up the powers. So 5 plus 1 is 6, plus 2 is 8. So my final answer would be 8 to the 8th. Now, in part C, it's going to look a little bit trickier because we have parentheses around the negative 3. All that is saying is I want to take negative 3, the negative and the 3, and take to the 3rd power. So remember, if there is not a power written, it's implied that it's 1. And so typically if there's parentheses, we're going to keep the same parentheses around it. So our base is negative 3 with parentheses, and I'm just going to add the power. So it'd be negative 3 all to the 4th power. And then finally for part D, I have b times b to the 3rd times b to the 5th times b squared. So again, remember that this is technically just b to the 1st. So my base is going to be b, and I'm just going to add up all the powers. So 1 plus 3 is 4, plus 5 is 9, plus 2 is 11. So I'd have b to the 11th. And now on to our next property, which is the power of a power property. It states, let a be a real number and m and n are both positive integers. So in words, it says to find a power of a power, you're going to multiply the exponent. So if I have a to the m raised to the n power, I'm just going to take m times n, so I'd get a to the m times n power. So here's an example. If I have 3 to the 4th raised to the power of 2, or you would just say squared, I would just take 4 times 2, so I'd end up with 3 to the 8th power. So a power to a power, you multiply. So here's example number 2, use the power of a power property. So just like before, we're going to leave these in exponential form, meaning we're just going to leave it as 3 to the 3rd or 4 to the 10th or whatever the case may be. So we have a power to a power, so we multiply. So this would be 7 to the 20th power. For the next problem, don't be confused by the negative 3 with the parentheses around it. We're just going to keep the negative 3 in parentheses, and then I would take 4 times 2, so it'd be negative 3 raised to the 8th power. Again, those parentheses just mean that when I take the negative 3 to this power, I want to take the negative to the power and the 3 to the power. For part C, we have y to the 3rd to the 3rd, so I would just power to a power, so I multiply, so it'd be y to the 9th, since 3 times 3 is 9. And then finally, we have n to the 8th in parentheses squared and then raised to the 9th power. So I would just keep the n plus 8 in parentheses and then multiply the 2 times the 9. So I'd get n to the 8th all raised to the 18th power. Make sure you keep the parentheses around the n plus 8. And now our next property is the power of a product property. It says, let a and b be real numbers and let m be a positive integer. So in words, to find a power of a product, remember product means to multiply. So if you look down here, we have a times b. So a power of that product, so it was a times b raised to the m power, find the power of each factor and multiply. So if I have a times b raised to the m power, I'm just going to take a to the m power and b to the m power. So if you look at the example, 23 times 17, so we have a product, raised to the 5th power. Rather than taking 23 times 17, we're just going to kind of distribute this power, and it would be 23 to the 5th power times 17 to the 5th power. So again, it's as if you're distributing the power to the powers on the numbers within the parentheses. Example number 3, use the power of a product property. So in part A, it says 34 times 9 to the 6th power. So keep in mind that there are powers of 1 on the 34 and the 9. So when I take everything to the 6th power, I'd be basically just taking 1 times 6 and 1 times 6. So I'm going to keep the same bases, 34, and then it would just be to the 6th power, times 9, again to the 6th power. So my final answer would be 34 to the 6th times 9 to the 6th. When I look at part B, I have 4mn all raised to the 3rd power. Once again, every one of those has a power of 1 on them. So it's kind of like I'm distributing that 3 to them. So it'd be 4 to the 3rd, m to the 3rd, n to the 3rd. You could complete this by actually multiplying out what 4 to the 3rd is, which 4 times 4 times 4 is 64. So I'd have 64 m to the 3rd, n to the 3rd. And now looking at part C. Part C brings up a good point that we'll see a lot in this chapter. We have negative 2g raised to the 4th power. So we have to not just take the 2 and the g raised to the 4th power, but we also have to worry about what happens to a negative when you raise it to a power. So just doing a little side work here, if I take a negative times a negative, I get a positive. If I take a negative times a negative times a negative, I get a negative. If I take a negative times another negative times another negative, so 4 negatives in a row, I get a positive. And then if I did 5 of them, I would get another negative. So if you have a negative number raised to an even power, so like 2 times or 4 times, you're going to get a positive answer, meaning the negative will go away. If you have a negative raised to an odd power, so like 3 times, it's going to give you a negative answer. So in this case, I have a negative 2 raised to an even power 4, so our negative is going to go away. If it was negative 2 raised to the 3rd power, which is odd, the negative would stay. If it was negative 2 raised to the 5th power, the negative would stay, but if it was negative 2 raised to the 6th power, which is even, the negative would go away. So in our case, once again, it's a negative raised to an even power of 4, so our answer will not be negative. So I'm just going to raise the 2, which is to the 1st power, and the g to the 1st power, all to the 4th. So 2 to the 4th times g to the 4th. Again, my negative went away since my negative was raised to an even power. I can multiply this all out and take 2 times 2 times 2 times 2, which is 16, and then it would just be g to the 4th. And then when you look at part D, we have a negative sign outside of the parentheses. So this negative sign is not being raised to the 2nd power. The only things that are being raised to the 2nd power are the 5 and the x. So that negative sign is just going to hang out in front while I deal with what the 5 and the x would do when it's raised to the 2nd power. So once again, there's technically 1s on the 5 and the x. So that would turn into 5 squared x squared. Again, it is only the 5 that's squared, so this negative sign is going to stay where it's at. So it'd end up being negative 25x squared. The only time you're going to square that negative is if the negative 5 was in parentheses. But again, the 5 is the only number that's being squared, not the negative sign. So it ended up being negative 25x squared. We'll be doing a lot of work with this negative stuff, whether the negative is raised to a power or it's not raised to the power, or whether the negative is raised to an even power or an odd power, knowing that students normally get confused on all of those negative rules. So just rest assured that we'll keep working on the powers of the negatives going forward. Another thing that you'll see in this section is something called the order of magnitude. A quantity can be defined as the power of 10 nearest the quantity. So basically, you're just going to be rounding up to the next power of 10. So like 100, 1,000, 10,000, 100,000, so on and so forth. So 91,000 would be rounded up to 100,000. That's the next closest power of 10. So then when I want to write it as a power of 10, you just count the number of zeros. So 1, 2, 3, 4, 5. So it'd be 10 to the 5th power. 956 would be rounded up to just 1,000. There are 3 zeros, so I would say 10 to the third. So you just round up to the next 1,000, 10,000, 100,000, 1 million, whatever the case may be, and then just count the number of zeros, and that will help you figure out what power of 10 that would be. So now we're on to example number 4. A box of staples contains 10 to the fourth staples. How many staples do 10 to the second boxes contain? So let's just think about this. If it said that there were 200 staples in a box and you want to know how many staples were in 2 boxes, you would just take this number times that number. This is not going to change at all just because we have 10 to the fourth and 10 to the second. We're just going to take 10 to the fourth times 10 to the second. Since I'm multiplying and I have the same base, I'm just going to add the exponent. So there would be 10 to the sixth staples total in all of the boxes. If you want to write that out longhand, that would just be a 1 with 6 zeros, which is 1 million staples. That's it for this section. Make sure you jot down anything you don't understand that we can cover in class before we move on, and we'll see you then.